Welcome, everybody. Welcome to those watching back on YouTube. This call, we've talked a lot about, zkApp architecture, what you can build, ideas for use cases, but we thought it would be interesting to go down the route of what some of the constraints are. And as Mina's blockchain is architected quite different than other blockchains, and the zkApp's model is structured quite differently as well. There's different constraints that are introduced, and bringing those constraints into the design process for when you're thinking about what to build and how to build it can be an important or a useful way to think. So Teddy and I were thinking about this a couple of weeks ago, and we thought it would be a great fit for a community conversation. I'll turn it over to Teddy to kind of introduce himself, but I'll just also give the plug at the very beginning that we're doing many of these. We've kind of been averaging a couple per week. And so if you have an idea for a community topic conversation at any point throughout zkIgnite, please let us know on Discord, and we'll help set it up and facilitate that conversation as well. So yeah, happy to have everybody here. Teddy, I'll turn it over to you to maybe if you could start by introducing yourself, and then we can kind of just let the conversation go from there.
Oh yeah, okay. Hi everyone, I'm Teddy. I work on the Foundation's product team. I'm super excited to join Mina. Been a big fan for quite a while, and everybody is so nice and wonderful. So I really appreciate being invited to speak to you all for the first time. Hopefully the first of many. I have an engineering background. I have a mathematics background. I contribute to open source software when I can, but I think most importantly, it's probably best to say that I'm here to support you. So wherever you see me, feel free to say hi, ask me questions, let's chat, let's talk about Mina, let's talk about zkApps. I'm here for you guys at the end of the day. So I think probably I should address the title of this, and I think the title was, what should your zkApp not do? I don't incredibly intend to go down an architectural and technical route. I think I would like to leave this a little more free-flowing about how can zkApps bring perhaps like efficiency to inefficient markets. How can we better define value propositions and things like that? So I hope I haven't scared anybody away from this discussion. But yeah, it's not about what the limitations of zkApps. That's a completely different thing. But perhaps introducing constraints to what we build, because if this discussion can be about how we use negation or lax, so I think in marketing it might be called negative detailing, to actually add value and properly define or design requirements for zkApps. Inherently, what a zkApp shouldn't do can clear up many of the value offerings, and perhaps improve the likelihood of network effects and moats or creation of moats for your zkApps. I think that specifically, this will better instill confidence in user bases, because telling users what you can do doesn't necessarily also tell them what they can't do. So I think it creates much more interesting value propositions for zkApp. So the goal of today's meeting really is just to engage with you guys, see what you're building, see how the use of negation, negative detailing might help you take the first step. So that's sort of my introduction. I can give a little longer into this, but it's an approach that can help us better manage expectations, right? So when we're delivering features, we might want to manage expectations precisely what users can do. I think it really sets us along mile markers towards not just proof of concept, but minimum viable products and many iterations long into the future. And I think it can do this by constraining us in scope, helping us better define the first step, because that's probably the hardest thing to do. So really, I want to talk about this today, and how we can better define value offerings to zkApps, improve the likelihood of network effects with moats, for moats creation, with simplicity, embeddedness, defining first steps, and importantly, building confidence and trust. That's my quick overview before we hop into the first topic. So I wonder if anybody really thinks about using negation in their development cycles or product requirement solicitation processes.
Could you explain a little bit about what negation is? Sorry to be such a noob.
Yeah. So, for example, using negation for specifically the perspective of zkApps, I think one interesting example is a keyless wallet. It is a wallet without keys. And so by saying that it is something, we also say it is not something. So it gives us a clearer view of precisely what are we hoping to deliver to the market, what are we absolutely hoping to bring to our users, so that they better understand what they might be using and how they might interact with the zkApp.
So just to repeat what you said, negation is saying what a thing isn't.
Mm-hmm.
Yeah, that's really good. And by the way, I love the idea of a keyless wallet. So yeah, thanks for bringing that up.
Yeah, I think it's super interesting because it's probably the most succinct way, but pun intended for snarks, but I think it's the most succinct way to define precisely what it is by including what it isn't, a wallet without a key or without keys. Anybody else have any other thoughts on including or negation or negative detailing in their product processes or development processes? Otherwise, I can hop into a couple of examples about better defining value offerings or value propositions.
Well, this probably might this might go down the route of where the prompts are headed. So if we are going that way, you can just tell me to shut up. But I think when I first started learning about some of the like valuable properties of blockchains and what you can build with them, I think the term like a shared database gets thrown a lot. Like a shared database that anyone can access, read, and write to is kind of a term that gets thrown around a lot. That was also like no one controls and can be owned by its participants or governed by its participants. But no one, well, in a decentralized way, no one person operates unless there's something wrong with it. In that way, I think like Mina can be confusing to new entrants coming in because not all of the data, or all of the data is not stored on the blockchain itself. Instead, just a proof. A proof of the latest block is that the latest block is correct is what gets stored. And so I think starting with that frame of mind of like Mina is not a shared database, instead of it's a collection of proofs that the current state is valid is something that I think it's an interesting framing in terms of what is it not. That could be a contentious thing, and I kind of want to like purposely start off with something a little spicy to see how others would describe that, or if there's a better framing in terms of what it is not from a one-line perspective. Yes, there we go.
Is this like the jokes in Borat, where you have to add not at the end, or?
I'm sorry, I can't really hear you, Matej. Was that just me, or? Oh, no worries. Oh.
But I think you raised a really interesting point, Will. Borat not jokes, yeah. Sort of a Cambrian explosion of blockchain applications, of blockchains in general, came about this idea of this shared ledger without a centralized institution, a centralized agency controlling who can read and write from it. And that is inherently sort of one of the value propositions or value offerings for ledgers. Mina being slightly different, Mina being the succinct ledger without replaying transactions, without storing the entire chain state on chain. It introduces us into a different paradigm. And I think because we exist in that different paradigm, it's important to define precisely what we're not doing. Daniel, go for it.
Yeah. Okay. I don't know if it's a good example, but I will try. I will see. So what I'm trying to build, for example, it's a real estate app where people have like the governments, and where you don't have to show how much money you have in your wallet, or for example, if you have a job, or if how long have you been employed, just a proof that you have work. And I'm trying to build this mechanism where other people can validate your contract and add this this proof on the blockchain, so that when you want to rent a flat, for example, you just show the proof that you are like employed, but they don't need to know who employed you, or the amount of money that you have, or something like this.
I think this is particularly privacy preserving applications, or applications with the information is inherently defined by lacks. I can prove to you something without revealing my income history, without revealing my employment history. You only need to know the bare minimum amount of information. I think this is an interesting topic, not just from this perspective, but also more broadly. When you think about things like users wishing to transact, in this example of paying rent, for I guess is an interesting scenario. You probably want that person to be KYC'd, or you want that they're good for the money, right? But I think it's inherently interesting because you can also prove the other side of that as well, that your zkApp is compliant with jurisdictional regulations, that you are offering housing, offering places to live to people of accredited jobs, for example, of appropriate income.
And I'm thinking to have like a validators where people can subscribe to become a validator, and they can receive like so people will have a trust score as well, and they will receive like an increased score every time they validate someone, or they validate a rental contract, or for example validate the ownership of a property. And it will go around like this, where people can validate each other. And if let's say a conflict arises there, it will trigger this mechanism where randomly will be picked up some validators, and they will have to solve the issue, and they will receive an amount, or let's say increasing their trust score. And that's it from me. Thank you.
No, that's really interesting. Yeah, I wonder if anybody else has some thoughts like this too.
Yeah, just going back to your idea of the keyless wallet, it's actually one of the reasons I'm here. I'm really here mainly for voting applications, but I did recently make an attempt at a keyless wallet for Cardano, and the problem with that is that smart contracts on Cardano are immutable, and so the attempt was to fix it so that a smart contract was kind of like a UTXO, where you would actually roll the funds to a new contract every time you needed to make a change. But anyway, it didn't work out so well. And one of the things that I'm finding out about Mina is that smart contracts are mutable. You can change them and update them. And so anyway, so I'm really excited about that. And that's one of the reasons I'm here.
Awesome. I love this idea of keyless wallets. I think that, as I said at the start, that inherently interesting because they succinctly state precisely what they do. And I think they offer a very different value proposition than other wallets in the ecosystem. And I sort of think the same applies for many applications. Like if you want to think about another one, would be, saying something is without like a DEX. Most people who use DEXs can be subject to MEV attacks, right? So having a DEX without MEV risk is inherently a unique solution that allows people to continue to have the same decentralized exchange or trading experience that they might have, much like a keyless wallet still allows people to transact on chain. just without the complexities that one might have experienced by storing private keys, however they deem necessary. So I think it's really interesting to help better define who the users are by the use of negation, because what we can do is we can say we want to build a DEX, but a DEX can be for everybody, or a wallet can be for everybody. But specifically, if we say a DEX without minor extractable value, or MEV attacks, or a wallet without a key, we specifically target a very small set of users, or a very specific use case that might not have been prevalent on the first steps of that application development. So I think it's really interesting to hone in on these use cases, because it more appropriately defines the value proposition or the value offering that these zkApps are bringing to market.
Yeah, one of the it's a gigantic problem with crypto is that people are passing away and family can't get at the funds. As a matter of fact, I just met someone in a park yesterday, because I'm always striking up conversations about crypto, and I met someone yesterday that has an uncle that passed away, and no one knows the 24 words for his Ledger wallet. And so what I'm imagining is some sort of a timed option where if you don't interact with your wallet, say within 6 months or a year, it's assumed that you're dead, and then it becomes possible for family members or whatever to collect those funds. And it could also be used if you lose control of your wallet. You wait a little while and you can get it. So, but I think this is really preventing adoption in the crypto space. And if that problem could be solved, I think we'll see a lot more people. This is why people still use banks, I think.
Yeah, I think that's super interesting, John. Anybody else have some thoughts that they'd like to share about what they're building and how negation or defining lags might better improve their value proposition?
So we built, let's say, some like roll-up tooling for Mina, and when I go through the crypto Twitter, you are usually seeing people like discussing different products, and I think that could be a good negation. There's like a lot of zk EVMs popping out there, and if you just say that like you're not another EVM rollup, or you don't have to learn another programming language to use our tools, that could be some interesting, spicy marketing, I think. It's probably something that we'll use, so sounds like a good idea to me.
Absolutely. In addition to saying what something is not, I think it's important to say and why. So Mina is not an EVM blockchain, and that's a good thing, because it's succinct. It allows for it has a smart contract language that allows you to abstract over zero-knowledge circuits with snarky.js. It is without solidity. It is without the problems of solidity. So I think that it's an incredibly interesting marketing avenue as well. But yeah. Any other thoughts? Will, go for it.
Yeah, I just want to build a question for the group off of that, which is just based off of people's different people's interpretation of what are some of. I mean, we talk, I think, at a high level around what the attractiveness of being a non-EVM chain is, but specifically to the stuff that people are building in this room, I'm wondering if people can talk about what some of the reasons why that negation or that framing is valuable. Hey, Alicia, welcome. So maybe Matej, if I turn it back to you, what are some of the benefits in your opinion?
So solidity, and when it came out with EVM, it was quite nice, it was new, but the problem was that because it has to be like a constrained sandbox smart contract environment, you have some limitations to what you can do and cannot do. So to fix those limitations, people have been trying different architectures. Like if you look at, I don't know, the Cosmos ecosystem or something like that, where you have something like application chains. That's already the first difference between EVM and something else that came after EVM. But more specifically, when you compare it to how zkApps are built, it's a complete paradigm shift basically. So you have to throw out most of the EVM knowledge that you have if you want to write zkApps. And you have to approach it completely differently because thanks to zero knowledge proofs, we be able to move the computation to the client side. So that's a good thing for many different reasons. Because the chain can be faster, cheaper to operate, etc. Because all the execution happens on the client side, which would be a good sales point, for example, for decentralization, right? So if I had to do a sales pitch on Mina, this is probably something I would be talking about.
I might be wrong, or I might have misheard you, Mate, but I think you raise a really interesting point about computation on the client. And I think that's a really unique thing that Mina can provide, particularly for zkApps operating on edge devices, particularly mobile phones. This is not sort of an easy place for many blockchains to target because of their large state or reliance on third-party data providers that can help bring data availability to those applications in order to perform basic functionality. And I think that client-side computation really allows for the next part I would like to get on to talking about, which is the likelihood of network effects and moats. And that this idea of client-side computation really allows, at least in my opinion, for developers to create zkApps that are embedded in everyday user experiences, whether it's a keyless wallet or whether it's something that's perhaps more identity specific. I think that using negation and particularly thinking about client-side computation, we can better get at defining simplistic applications that can be really strongly embedded in everyday user experiences to bring about products that bring large network effects and increase its user base. Go on, hop in.
One problem with the client-side computation or off-chain computation is that it's pretty resource intensive. So even on like super beefy modern processors that we have today, which you normally see in like computers, you're still talking about like minutes that it takes to prove something on a desktop computer. So, but that means basically that we have a competition of like proof systems and who can build a better proof system that will be more efficient, maybe will run better on mobiles because it's like less resource intensive, etc. So in the mobile phones, it's like a bottleneck kind of because you don't have the computing power there. So
yeah, no. I think that specifically here on the topic of the discussion today is using negation to make sure that at least the zkApps that we develop are simplistic can be really important for building out the likelihood of strong network effects. I think one really interesting example is Aave, for example. Aave obviously started out as a very simplistic, straightforward lending and borrowing protocol without offering complex derivatives or sophisticated sort of tooling. But what it did find is that because it was so simplistic and so easy for developers to build on top of, that it could create a moat. It has this wonderful network effect of the large amount of liquidity on it, and it's so deeply embedded in many Web3 user experiences. And I think that has come about from the simplicity of its original design. Another example, I think, here in with the aspect of negation is Threads. Zuckerberg's newest product. It is Twitter without Twitter's product bloat. We have Twitter has lists and trending articles and blue tick marks, all these things now, right? But Threads is Twitter without the product bloat. So I think that bringing simplicity, using negation to help define simplicity really helps us build things that can be built on top of, allow for composability as time goes on, that the zkApps that we develop aren't ephemeral and can last long into the future. I wonder what everybody else is thinking on sort of the topic of zkApps as simplistic to begin with, in order to iterate into more advanced applications in the future.
So I think that like perspective, like from an engineering perspective, it won't impact the things I was talking about before, like the proving time, etc. Because the persistent Mina allows like several different features into like separate methods. So if the zkApp is super complex, it won't have that much of an influence into the proving time, right? So that was just a technical perspective, and from a product perspective, I think simpler. We should probably define what that means, because like if you make something for fun or as a non-profit project or something, then you can definitely allow yourself to keep the app simple. But I think if you are aiming a little bit higher and you want to have like certain profit from the app, like tokenomics, for example, could be interesting, and then it becomes quite difficult to keep things simple. I think even if you look at the simplest like stablecoin projects out there, they still have quite a lot going on.
Yeah, I'm curious to know what are some features of Mina that people deem most necessary or most important to bring about network effects, mass adoption. Perhaps it's privacy, but I'm keen to hear what others think. Matej, go for it.
I think I already mentioned basically, but even for the mobile phone or desktops, doesn't matter, any clients. The fact that you can verify things very fast in comparison to how long it takes to prove it. And thanks to how the overall protocol is designed, essentially as well, you can verify validity of blocks super quickly on any client, pretty much, even a mobile phone. So it means that you perhaps don't have to rely on like RPC providers. Like an infra scenario will probably not happen thanks to that. If they do, like I don't know, but like that's something that we could avoid. And I think that there's not too many zk protocols like Mina out there. In fact, I can't actually name a single one that has like a full zk protocol.
Yeah, I think those are all great points. What else have we got? Simplicity is key, user experience, idiot proof. Also, safety is important. Has to be trusted. It has to be trusted? Or do we need confidence in the application's use case to remove trust and only have confidence in its execution ability? Any other thoughts?
I see Andreas has got a +1. Do you want to, Andreas? Sorry to call people out, just in the spirit of getting a conversation going. Do you want to +1 vocally?
Yeah, I mean, I listening and I think really deeply about the topic, but it's hard for me to contribute something. But yeah, simplicity is key. User experience. I mean, I'm currently working on EC Mina, and this is what I'm currently doing, coding stuff up to make it easier. And yeah, and always if I talk with developers or so, they start with Ethereum and then they say, yeah, first they think it's like the same, but a little bit different. But it's very hard to understand the network itself. You know, what can you do? For example, I made a proposal for the last cohort, and was like an NFT like project, and it was very hard for me also to explain to other people, because it's totally different. You need to think differently. You know, you don't have like on Ethereum, everything is on chain and so on, and then you do it differently. And my attempt, for example, was made it with the events. You know, like you trigger you trigger Mina, and then you emit events, and out of the events you can build out the NFT. And it's like a different mindset. You have to think very deeply how you can do stuff. And yeah. And currently, I also all the time look into new use cases and so on. For me, it's like zk oracles is very interesting. Then everything around DAO and voting with the recursion and off-chain stuff, and yeah, and also data streams. I think data streams it's a really unique use case to validate data streams in some way. Yeah.
Thanks. Sorry to call you out of the blue, and
no worries.
Just to keep the conversation going. But can I ask one follow-up question around validating data streams? Like, can you just speak a little bit more about what that means in a Mina context?
Yeah, I mean, I saw also in the Discord conversations, it comes up in the last 2-3 months or so, indexes and indexing data and so on. And in my currently, I'm very into bitcoins and inscriptions and ordinals. This is like a new stuff there, and they have so many problems there to index the data. For example, you know, like there's an project called Bitmaps, and they have over 700,000 new inscriptions, and they have to find out what's the right order for that and so on. And I think this would be also a great use case for Mina to validate streams like this of data, you know, and make basically a sidechain for Bitcoin, for ordinals, for example, you know. And this is currently what I'm fascinating, and I think all the time about the combination of Mina and Mina and Bitcoin, this ordinal stuff, because they need this is urgent, you know. Everybody talks in this in the inscription community about indexes, but everything is centralized, you know. How we can do it decentralized. And yeah.
I think that's a really good point. And obviously indexes will long be a popular product on other chains. But it's all like, obviously we have things like the graph, for example, and they have means of validating state or proper indexing of information on chain. But when that's served to a user, I think is a very different thing. And the user being able to prove or verify, rather, not prove, the user being able to verify whether the state they were served is correct. So it almost formed like almost a light client, a security check. And so I wonder, Andreas, if you could define that almost sidechain of Mina for validating Bitcoin ordinals with a negation.
Yeah. For example, with this bitmap stuff, you know, the idea with bitmaps is you can claim a bitmap, and this is a number basically, and it's a block number. And currently the Bitcoin highest block is, I think, on 800,000 or something like that. Now, for example, a small problem, you know, what if I claim the number 1 million? Is it valid or not valid? Someone has to decide it. Or easy stuff like, okay, I want to claim 2 bitmaps. Can I do 1.bitmap, comma, 2.bitmap? Yes or no? These are very easy questions. This is one line of code, you know, like can you do this with split or not? But someone has to decide it. And these small rules are, this is a debate. If you include multiple bitmaps, for example, in one transaction, yes or no is, I think, a debate in this community for days or months, you know, this one comma. And that's why it's so important that these rules are somewhere public and provable. And I think this is it's a fascinating idea, you know. And that's why I also ask Angus about how big is Snarky.js in total, because it would be also possible to upload the JavaScript directly on the Bitcoin network, for example, and then prove on the ordinals protocol and send over to the Mina protocol a verification. And I think you cannot, this problem, you cannot solve it internally with Bitcoin alone. You need zero knowledge proofs. And there is, I think, a new opportunity for sidechains. And maybe it's not like in Ethereum you have like this idea of rollups, and they are directly, this is like a special interface for, you know, like for Ethereum had to implement a special interface that Arbitrum and so on can connect to. But maybe it's possible without a connection for this new inscriptions and all that stuff, you know, like. And I think this will become very, very big very soon. And Bitmap is right now the second biggest metaverse, and it's only one month old, you know, like it's amazing. It's like, yeah, but yeah,
I think that's a great answer.
I want to give room for other people. Sorry.
I thought it was a brilliant answer. I guess the definition of a negation is the ability to verify ownership of an or claim a bitmap for an ordinal without risk of a bad actor. I'm not sure.
Yeah, and also which data is included in the data set and so on. Very small, tiny things, you know. This would be as an awesome. These are awesome use cases. I'm totally bullish about it, and that's why I'm here for building on Mina and so on for the future.
Yeah, I think that's a really interesting point. Mina is great because it's not alone. We can use Mina elsewhere in the case Bitcoin. I think that's a super interesting example. Anybody else have any other thoughts on this sort of a topic about how Mina might act and help other scenarios? If not, I have another thought that's sort of similarly related to Bitcoin, particularly because I was quite inspired by Jonathan's zk Lightning Network, zk state channels, and brilliantly on the topic of discussion of defining things with negation. There is a section in his repository that says, you know, things we left out. And I think this is really interesting because he talked about, you know, we left out, for example, the ability to do multi-hop transactions and prevent fragmented liquidity. But instead, what they created was a brilliant ability to create a state channel between two parties. I think what negation does there is that it specifically said this is not for many people; it's specifically for two. I think that inherently creates a very different product, a very different use case, a very different scenario that can be really interesting to explore, and at least allows us to define the first step. Because when we dream of blue sky ideas, often we may struggle to get off the ground, particularly if you're building a rocket engine. Now, I think what negation really allows us here to do is define that first step. So instead of doing multi-hop, or let's just do transactions between two parties, off-chain, recursively so, is a really great way to define the first step to make sure that we can iterate going forward and that we're not losing sight of a larger goal. I'm wondering, anybody who's building something that has used some form of negation, some sort of technique like this to help define that first step, to help get their idea off the ground in order to just start building something. I'd be really keen to learn what people think in this regard. Or anything that might help a zkIgnite proposal. They can help refine it, make sure it's clear that there are steps defined to not just a proof of concept, but an MVP, and then ultimately far beyond that. If not, okay. There's another comment in the chat that I wanted to talk about a bit, and this idea of trust. I think it's a really interesting one to touch on, particularly for zkApps. Because ultimately what we might hope is that zkApps can be provable, that we don't need to trust them. We can have confidence in their execution because their scope is really well defined. So I think that not just from an end user perspective, one that is using a wallet, one that is using a DEX, not just that they can prove the execution of it, but also that they can have confidence and that there is that transparency that builds that confidence in users. So inherently in the scenarios where we can define what the application is not doing, we can inherently build that confidence and build that trust, if you would prefer to say, because its scope is well defined, its value proposition is well delivered. I'd be keen to learn more about what people are thinking about in terms of being able to instill confidence with their zkApps by perhaps saying this is not what the application does. But it precisely does this, and it does it well, and we can prove that it does this.
Maybe, all right, here I come again. So be careful, everyone. There's a separate conversation specifically around we had about 2 weeks ago around zkML and what, where Snarky.js could play a role in verifying the inputs and outputs of specific models, large language models. And I see Lee Kwan is on the call, and I was wondering, Lee, if you can talk a little bit about maybe Snarky.js in the context of zkML and maybe starting with in the theme of this conversation, where does it make sense to call out that zkApps don't play a role for zkML and where they shouldn't. It doesn't make sense to have zkApps proving either the inputs or outputs of models. Sorry to call random people out. Does anyone else have any thoughts on zkML in this context? I know it's a pretty niche subject.
Could you give us a quick overview?
It's not my domain expertise, so I might butcher it, but being able to say prove the output of a large language model that that the inputs what they say they were, but without revealing the actual data of what those inputs were. So you could say I ran a language model based off of these inputs. It proved this. It gave me this output. This output is public, but the inputs remain private. No worries, Yasin, we're good. Another example is you can potentially have a shared model. One of the topics that we discussed on the call itself was about co-computation for rare disease testing, where you have a pharma company. I'm oversimplifying this, but you have a pharma company, you have a who's developing a drug, you have a hospital who's testing the drug, and you have a regulatory body who is enforcing the results. And across each of these parties, they're running co-computations to prove that the result of the against a specific model to prove the result of the drug was tested, or that a disease is it is what the patient says it is, but revealing private not revealing private information along the way. So that was an example of what it could be used for, but I don't know enough about zkML as a specific topic to kind of frame it as what it shouldn't be used for. So that's why I'm kind of throwing this in the mix. Lee's back.
Yeah, hi. Yeah, actually, I was in the office, so I need to change to another room and.
Sorry.
Use my iPad. Otherwise, it's a little bit disturbing for other people in the office. So, yeah. But actually, it's quite. Yeah, actually, we already mentioned the most important scenario for zkML nowadays. Maybe later we will find more, but nowadays it's more like a proof you really use this model. And but actually for the something like a little bit larger model, let's say it's not just a simple linear model or something like I did before, like decision tree. If it's a quite big model, then usually people tend to prove the parameters, which means all the structure of the neural network. If we use the neural network, then all the structure, all the different layers, connections should be public. Not need to be public, but both known by verifier and prover. So which means we do not prove this part. This part is something predefined that should not be changed. The thing zero-knowledge proof usually can protect is the parameters. So which means although you use same network like CNN as they have done before, but different CNN networks usually the major difference are their parameters. So if you can prove, okay, I use this set of parameters and other people use another set of parameters, they may be able to classify different pictures. Like say the first one can classify the text, the second one maybe can classify different humans. That's a basic idea now, but actually but since you want to show other people you actually use this model. Of course, if you're just two parties, that's easy. You use a simple zero-knowledge proof commitment, that's already okay. But if you want to have a really public product, then that could be an issue. I mean, even if you actually put your model, you put your verifier on the Amazon's cloud service, but who knows, you didn't change that. So that's why I feel it's quite important for us to have something support zero-knowledge which machine learning on blockchain. So which means we can leverage somehow like zero-knowledge proof can prove something, but it also need to leverage the consensus or the trust from the blockchain itself, which means the model cannot be changed, the commitment cannot be changed, the verifier must be the verifier. You should not change to another one. That's quite challenging actually. And I noticed there are some works on zero-knowledge machine learning, but they mainly use the stack based, because it's like virtual machine based. It's a little bit easier. I'm thinking about if we can really merge this stuff into the Snarky.js. That's what I'm working on now, and I'm also looking forward to you guys' feedback. So, and also, not only proves machine learning. I mean, machine learning is just a type of computation. If you can prove other kind of computations, operations, you can actually support other service. Like I remember some guys has done like a fingerprint, right? Okay, and I mean it's like you can not only leverage the machine learning, you can also compress other computations on chain. That's the thing I feel most fascinating for me now. But it's still, I mean, still a lot of challenges. So I really hope you guys have inputs, ideas, and yeah, welcome join.
Thank you. That was very insightful. Mario, I think Mario has his hand raised.
Yeah, hi there. Sorry for being late. I have a question, yes, about this this ML or machine learning. I'm completely new to this, so I'm quite ignorant about this. So I think it's a newbie question. Sorry for that. But when you do machine learning, I think you have to, your inputs will be maybe thousands of or inputs. Okay, so you will have a lot of private inputs. Is that possible? Wouldn't it be quite a huge task to compute a proof of all private inputs that a machine learning model might need? Wouldn't it be like thousands of private variables going inside the proof? Wouldn't it be just too much for Snarky or for some contract doing that? So sorry for being so ignorant about this, but
I agree. I agree. I think you actually mentioned a very important challenge nowadays we are facing. It's yeah, it's important. I mean, I think you actually raised that question very important, a very important question. Now, first of all, actually nowadays people are or maybe can only prove the inference of, so which means you already train your model locally and you just have the inference of the model, which means it's a quite simple version. You just only make decision with this model. That makes the thing a little bit easier. So which means usually you do not need to face like a gigabit or terabit data sets. But input also very important because let's consider a scenario if you want to do the classification for figure. 255 times 255. So we already got 255 square parameters as input. Yeah, that's already a challenge. And if we are talking about something like a video, wow, that's gonna be very stressful. So now I feel that for machine learning on chain, we can still only support some simpler inputs. Let's say some data, some already let's say not figures, not videos. But from the text to figure to video, we can solve this step by step. We may have a better proof model. For example, the folding scheme, you may not need to prove all the things once. You can prove them separately and generate the proof at the end. But I must admit, it's still a challenge. And I assume there actually will be a lot of research on that. Because now that's a whole zk machine learning, you can solve figure issues. But for on-chain one, that's a big challenge.
Okay, thank you.
Yeah, zkML is super cool. particularly being able to prove that one model is not another. To go back to the discussion, I think it's super interesting and super valuable. Also for zkML, I guess, also being able to prove that your model was trained without access to, private data is also incredibly valuable, particularly when we think about how much data ChatGPT and other large language models are currently trained on, and they cannot, how difficult is it to prove that they were not trained with other data is a whole Pandora's box to get into. I think that the world that we live in the snarky world is inherently relevant to that, and to be able to prove compliance, to be able to prove that the thing that you built is reliable, can be trusted, there is confidence in its execution. I think it's an inherently really interesting area. But look, I think we're coming up to the top of the hour. So I hope I've at least touched on a little bit on terms of how using negation or defining things without lacks or what they're not, for value propositions, for perhaps improving the likelihood of network effects and building moats, or defining first steps in terms of development cycles, has been at least somewhat interesting. If I can ever be of use to anybody in the community, just feel free to drop me a line. Just give me a wave wherever you might see me, online or in person, doesn't matter. So thanks for listening to me, and I'll pass it back to Will.
Great. Thanks, Eddie. And just as a final closing note, if anybody has any conversations they want to continue, like this one or another topic over the next week or couple weeks, just again hit us up on Discord. Otherwise, final reminder, or not final, we'll definitely say it again, but proposals due July 12th for zkIgnite Cohort 2. Those are just the drafts. You can update them, you can edit them, but if you don't have something posted by July 12th, then you won't be able to participate as a proposer for Cohort 2. You'll still be able to join other people's teams, and there's many other opportunities, but just, that's the final draft deadline. So with that in mind, thanks, Eddie. We'll see everybody next week. But if you have any other questions, we'll see you on Discord.
Thanks,
All right,
Nolan.
thank you.
Bye-bye.
Bye, guys. Thank you.
Bye.